Good morning, Year 6. Happy Wednesday. Today you have maths, you have reading, and you have topic. And your topic is connected to, it's the same slides as yesterday. All week you're working on a project where you will be designing an Anderson shelter, drawn to scale and building it if you can. So this slide tells you what Anderson shelters were. You can see a picture of one at the bottom. They were shelters that were designed to protect from bomb blasts. They were made out of corrugated iron, and they were built kind of part under the ground and part on top of the ground. You can see the real life measurements here, 6'6" by 4'6", which is 1.95 meters by 1.35 meters. Now, if you were going to make a scale model of that, you need to think about making the height and the width all smaller by the same amount. Scale means that the dimensions stay the same, the proportions stay the same. So if you're making something smaller, it gets smaller by the same amount in the height, the width, the length. So there are slides that you need to go through about scale. You can see here that a real life Anderson shelter was just slightly taller than the average height of a person, 6'6", 1.95 meters. You can see the picture of the people in there. And then there are a few questions about how big you think a model should be if you were going to make a model. There's an example on there. Do you think that the model should be the size of a human as well? The same size as a real life Anderson shelter? Do you think it's more like the size of a table, more like the size of a book, more like the size of a pencil sharpener? And this one here in particular is probably about the size of a book. A pencil sharpener would be too small. So how many times smaller is a book than a real life Anderson shelter? So we can look the real life one, 195 centimeters. 1.95 meters is the same as 195 centimeters. So that's kind of up to about here. Up to about here. A lot taller than me. And then you've got your book, which is about 19.5 centimeters. And how much smaller is that? We've been doing some work on dividing by tens, hundreds, and thousands. So which one do you think it is? Yeah, it's 10 times smaller. We divided by 10. So if the width of a real Anderson shelter is 1.35 meters or 135 centimeters, what would the width of the model be? 13.5 centimeters, dividing by 10. So you've got these measurements. You're going to think about materials. What do you think the model's made of? The real life one we said was made out of corrugated iron, so a type of metal. And why do you think it'd be made out of that? Think about what the materials would be used for and why we would choose particular materials. And this model of the shelter, we wouldn't be using the same materials for the model. Think about what we might use. Then you're going to make your design. You can see that a design here has some labels to explain what things are for. If you click on this picture here, it will take you to more information about Anderson shelters. Then you're going to make your model when you've designed it. Okay, so it needs to stand up by itself. It needs to be a scale of the original. And it has to have a door that opens and closes. So we're going to be using that when we look at electricity and when we look at making circuits. You are going to need perseverance. You're going to need to revise, go back and fix things. That's what we do when we do design and technology. And imitation. Someone's already made this before, so what can you take from theirs that would be really useful? I notice how others do things and improve my own learning. When you've done your design, or you've managed to make your model, which would be amazing, you're going to evaluate it. What went well with it and what would you do differently next time? When you've done some work on this, whenever you do it throughout the week, you can upload work for us. And there is a Wikihow page linked to this piece of work that will tell you how to do that. to upload work and share it with us. Then we're going to look at circuits. So here is a circuit. Some Anderson shelters had electricity and there was a light inside, but the light turned on when the door was closed. Think about why the light would have to turn on when the door was closed, not when it was open. And think about how an electric light works. There's a circuit for you to look at. And then we're going to talk about what's wrong with circuits. So this circuit, there's something wrong with it. Can you work out what the problem is? And then what do these symbols mean? Because this circuit here has had the labels on there. Sometimes lamps are drawn as crosses instead of the way these are as well. You might see that sometimes. So what is each thing on this circuit and what is wrong with the circuit? And then what's wrong with this circuit? It's another circuit. What can we find? Then you're going to draw a circuit for us, which has a switch and a bulb. Right. Here is the Wikihow document that you can scroll through. So when you add and create, you can start your own piece of work and then you can add it and attach it to the assignment and see if you can share your work. There's a second method here. And that's about a quiz. Right. Enjoy your day. Can't wait to see your topic work this week.